This two-part video, we'll be diving into the tracheal systems of insects. In part 1, we'll explore the structure and function of simpler tracheal systems, for example that of the larval stage of the darkling beetle. Breaking down how these fascinating networks deliver oxygen throughout an insect's body. Then, in part 2, we'll move on to the more complex tracheal systems, for example that of the wasp.
So I'm going to say that this video concerns the tracheal system of the larval and then the pupal stage of a couple of insects. I've deliberately taken ones that undergo a complete metamorphosis, in other words, egg, larva, pupa and adult. I'm going to start with the larval stage of the darkling beetle, in other words the familiar mealworm, and then I'm going to look at both the caterpillar and chrysalis stage of the blue morpho butterfly, and that's all we'll cover in this video, and we'll have a separate video looking at the tracheal system of an adult insect, and for that I intend to use as my model the Vespular wasp. So starting with the darkling beetle, dissect, and I'm going to start by going to the 3D view, and I think you'll be able to see that this is taking in the head with the antennae and mouth parts. It's taking in the pro, meso and metathorax, and 1, 2, 3, 4, the first 4 abdominal segments. If I turn it round, we can see the various internal structures. Now, in best Blue Peter fashion, I have segmented out the air passages, the tracheal system, before starting. Now, the default from the vast majority of insects is to have 2 spiracles on each side of the thorax and then 8 down the abdomen. In other words, a total of 10 spiracles. Note that there are no spiracles in the head, unlike us, and we breathe through our nose and mouth. The insect's first spiracle breathing hole is somewhere round about here, as you'll see in a moment. So I'm going to change this to the maximum intensity projection so I can delineate the tracheal system. Now you will say, but surely the tracheal system is full of air, and air has an extremely low attenuation and is therefore black like the surrounding air. But what I have done is to invert the situation so that the highest is the lowest and vice versa. So let's look at this now. So this is the first thoracic spiracle, and this is the second thoracic spiracle, and here we have the first, second, third and fourth abdominal spiracle. As we have said, there is no spiracle in the head, but there are branches passing from that first thoracic spiracle. In fact, there are 2 on each side. when we look at a chrysalis later on, you'll see how much more complex this becomes. But the simple thing about this system is that in each abdominal segment we have a spiracular branch, we have a lateral branch going to down, a lateral branch going up. We have branches passing dorsally up towards the heart, and we have branches passing ventrally down to the ventral nerve cord, and then we have these branches which are passing to the gastrointestinal tract. Now, this particular insect happens to have a very simple gastrointestinal tract, as you'll see in a moment. Now, we can also see branches of the tracheae passing down into the three simple legs. The other way, of course, to demonstrate this is to go back to the volume view, and now instead to alter the windows and levels and basically say I only want to see the tissues of highest attenuation, which are the trachea, because we've inverted it. So if I move this along, we should gradually get rid of the exoskeleton, and we should have, I stop that for a moment, and we should get rid of these low attenuation air passages and just leave the tracheal system. Famous last words. Here we go. Here we can see a lot of the low attenuation fat globules. This is the lumen of the bowel. So if we go further across, we should get rid of the fat and just be left with the tracheal system, which indeed we do. So that is a very simple tracheal system of a larval beetle, a mealworm. And what I'd like to do now is look at the equivalent in a butterfly at its caterpillar stage, and then go on and looking at a rather more complex situation developing as the chrysalis turns into an adult and gets structures such as wings and so on. So this then is the blue morpho at the caterpillar stage. And I'll make the point that this is exactly the same as the mealworm, with 2 spiracles in the thorax and 8 spiracles in the abdominal segments, and again with this very simple arrangement. We've pointed out the teeth, and what we're now going to do is to go on to the chrysalis stage and just look at which bits are very similar, particularly the abdominal segments, and the much more complex situation developing as the insect metamorphoses. these spiracles, the abdominal ones, maintain their very simple situation, whereas those in the thorax and head are developing structures as the wings and the antennae and the tongue, the proboscis. In my view, the best way to delineate the tracheal system of an insect is to take the low attenuation black tracheal system, reverse the data, and it's so much easier to see the high attenuation white structures rather than the low attenuation black ones. And we'll go on to look at a adult wasp in a minute.